Hi guys, last class we had an introduction about electricity. So, electricity is defined as the movement of charge around a circuit. So, that we call as electric current. Electricity is defined as movement of charge around a circuit, which call this electric current. And we learned about charges are the two types, positive charge and negative charge, and negative charge are carries by electrons. So electrons only move within the circuit. Now electric current is given by symbol capital I, and electric current is defined as movement of negative charges in a circuit. Here negative charges are nothing but electrons. So we can define current as the amount of charge flowing per second and is given by the unit current amperes. So the current is defined as the amount of charge flowing per second in a given unit of time. Current units are amperes, or we can define current as the rate of flow of charge. So if current is charge flowing per second, then we define current in formula current I equal to Q upon T. So here Q is charge in terms of coulombs and T is time in terms of second. So amperes is defined as charge upon time or coulomb per second. Now current of 1 ampere is 1 coulomb of charge transferred in 1 second. That we define as 1 ampere. So it is a division. If you get 1 ampere, so I can get it here. If it is 1 coulomb of charge divided by 1 second of time, then we get it here 1 ampere of current. So this is what we define in terms of coulombs. Now this also can be rewrite as Q equal to I times T or T equal to Q upon T. So let us take a problem. Suppose the problem is like that. If certain current is flowing through the bulb by an amount of time, so how much charge is used by the bulb? Let me take the problem first. So the given question is a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. So let me draw a quick diagram. So this is an electric bulb which is having filament, and this is connected to a circuit. So this is a cell symbol. Oops. Yeah, this is positive and this is negative. Now given that, so when current is flowing, so the cell is utilized by the bulb starts to glow. So it starts to glow. Now here the question, find the amount of electric charge that flows through the circuit. So I need to find charge. Q equal to how much? Sorry, Q we are representing capital. Anything you take, no problem. And time T is equal to given 10 minutes. And current I equal to given that 0.5 ampere. So we can write the formula current I equal to Q upon T. So this is also, we can write that Q equal to I times T. So substitute the values at here. What the answer we will get? So if you can write that Q equal to I is 0.5 ampere times T is given 10 minutes. The 10 minutes we convert that in terms of second. Therefore Q equal to 0.5 times 10 times 1 each minute contains 60 seconds. Now Q equal to 0.5 times 600. So I can write that Q equal to 0.5, I can write like 1 by 2. 1 by 2 times 600. So you can cut that in terms of 300. Therefore Q, the charge, Q equal to 300. Charge units are coulomb. So this is how we need to calculate the amount of charge. So here coulombs are very big units. So let us ask a question. How many electrons? How many electrons contain in 1 coulomb? So in 1 coulomb, how many electrons are there? I would like to know that in 1 coulomb of charge, how many electrons are present? I need to know the number of electrons in 1 coulomb of charge. So let me take that problem at here. So I have a problem. How many electric charges form 1 coulomb of charge? And we know that charge of electron, charge of an electron equal to 1.6 times 10 power minus negative 19 coulomb. So to find the number of electrons, here we are going to use one relation. Charge to electron, charge Q equal to Ne. So here N equal to number of electrons, electron number, and E equal to charge of electron. So this is the one more formula I am giving today, charge and electron relation. So Q equal to Ne. So here it is asked that 1 coulomb, how much charge they are given? They are given that 1 coulomb of charge. So Q equal to 1 coulomb. So we can substitute that in this formula. 1 coulomb equal to, we need to find the N number of electrons times charge of each electron, that equal to 1.6 times 10 power minus negative 19 coulombs. Yeah, both side coulombs are units, you can cancel that and do the rest of simplification to find the N. Therefore N equal to, so 1 upon 1.6 times 10 power negative 19. So if you can do this simplification, that I can write that 1 upon 1.6 times 10 power positive 19. I send this 10 power 19 to numerator. So this we can get in terms of n equal to 0.625 times 10 power 19. So also we can write that 6.25 times 10 power 18. So 10 power 18 is very big number. It means after 6.25 we need to put 18 zeros. So if we can write that in terms of a number, therefore n equal to 6.25. So 625, after I need to put 16 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So these many electrons are containing in 1 coulomb of charge. See how much big number it is. So in 1 coulomb of charge, these many electrons contains. So that's why 1 coulomb is very big unit. 1 coulomb is very big unit. So this is the reason we will represent charge in terms of smaller unit. 1 millicoulomb. I hope you know what's the value of milli. Milli means 10 power minus 3 coulomb. Or smaller than this. Smaller than this, we will represent 1 microcoulomb. 1 microcoulomb. Micro means its value 10 power minus 6 coulomb. And smaller than this, 1 nanocoulomb. Nano means 10 power minus 9 coulombs. So 1 coulomb is very big unit. So that is the reason now we will represent charge in terms of slower units. 1 coulomb is very big unit because 1 coulomb contains 625 times 10 power 16 number of electrons. So we will represent charge in lower units in terms of milli. Milli means 10 power minus 3. Microcoulombs. Micro means 10 power minus 6 coulombs. And nanocoulombs. Nano means 10 power minus 9 coulombs. So like this smaller units of charge we will represent. So here to find the charge and the number of electrons. So this is the formula, new formula. We will use the relation between charge unit coulomb to number of electrons. So this is all about how to find the coulombs, charge and the amount of current. Now today's class, let us change the concept. Ask a question. What makes a charge to move? A charge to move. So how a charge moves? To move charge, what it is required? Remember carefully. Where these charges are contained? These charges are contained in conducting wires. Conducting wires or metal wires. So let's try to understand how a charge moves. Suppose this is the connected circuit. I connected bulb with wires and here small gap is there. Suppose, what can you guess? If I connected these wires like this, what is the reason the bulb is not burning? So here electrons are present. Yeah, electrons are present. Here you can see electrons are there. So these all are electrons. Electrons are present since electrons are there in the conducting wire. But electrons are not moving. Electrons are not moving. So why the electrons are not moving? Let us try to find. Is the switch is reason? Suppose if a connected switch in the given circuit, and if I on the switch, now the switch is on, but still the electrons are not moving. So that's the reason here the bulb is not burning. Now what makes an electrons to move? Suppose if I cut at here, if I join in this, the very important thing at here, this is known as cell. Now here you see electrons are moving. So when electrons move, that contributes current. Now to move the electrons, what could be the cause? Yeah, this component at here. So this is known as battery. So batteries here acts like source. So if you can increase the power of the battery, here you can see it's having 9 volt. I can explain about the volts later. If you can increase the strength of the battery, so the strength of the battery increases, the electrons are moving in the wires through battery or more, and while they are moving, they carrying charge, and that charge is used by electric bulb. So if you can increase the strength of the battery, so electrons will flow faster. So it means they contribute more current. So if the battery capacity is less, means power is less. So if you can take 6 volt, now you can see the intensity of the bulb and how slow these electrons are moving. Now if you can increase this to a 50 volt, see how electrons are moving faster. Now to move electrons, here something is needed. That something we call in this electricity language, that is known as potential difference. So this term is here very important. To move electrons, the needed thing here, it is potential difference. If there is no potential difference, so here cell is off. There is no potential difference. Now right now no potential difference. So here it is no potential difference. So here no potential difference. So electrons are not moving. They do not move. So if they do not move, the bulb, it won't function at all, because no current is flowing through the bulb. So to move electrons, what it is required? Here is the required thing is that the cell. So the cell is the very important component at here. So the cell having the capacity, when we increase its capacity more and more, when the battery capacity increase, the more electrons will flow. The battery here provides the potential difference. So the potential difference is the cause to move the electrons within the circuit. So potential difference is something like that. We can express this potential difference as electric pressure. This is another word for potential difference, which is known as electric pressure. So we know the importance of pressure. Water always flows from high pressure to low pressure. If there is no pressure difference, water, it won't flow at all. So that's the reason water always flow from high pressure to low pressure region. So in this case, how water flows, similarly as like that same, the electrons also move from high potential to low potential. So here within the cell, if we can see, so this point we take it as this is positive to a cell and this is negative. Cell having two terminals, one is positive, another one is negative. You can see electrons are moving from positive to negative. Why they are moving from positive to negative? Because to the cell or battery, here I supposed to call this as battery. Let me say the difference between cell and battery. Battery is the combination of cells. Cell is single, but battery is more number of cells. If we connected more number of cells, then that becomes battery. So whenever I use the word cell or battery, it means the meaning is same at here. So come back. Now the cell here having two terminals, one is positive and negative. So positive is having high potential and negative is having low potential. So this potential difference, because of the potential difference, then the electrons are moving at here. Now this potential difference we can measure with an instrument known as voltmeter. So this what I was connecting at here, I am connecting at here. This is a digital voltmeter. So this voltmeter tells about how much potential difference is existed in the battery, across the battery. Now if I decrease the potential difference, now here I am decreasing it. Now let me take all the way to 0. So 0 potential difference means there is no potential difference between the positive and negative. So here it is showing that 0. So that's the reason electrons are not moving. So this is the case which happens usually whenever our clock won't work. Suppose our clock it won't work, we will first change the cell. So what we think? We think that the cell is dead. Yeah, if you use the cell, obviously the chemical energy in the cell that will get over. The cells are having chemical energy, so that chemical energy here used to convert in terms of electric energy. So these cells, if used continuously, they will lose its chemical energy. That chemical energy right now at here becomes 0. That's why it is showing 0 volt. Suppose if I increase this a little, you can see now here it is 4.5 volt. Now 4.5 volt is the potential difference between positive terminal and negative terminal of the across the cell. So without the existing of the potential difference, electrons they do not move in the circuit. So this is very important point. So without potential difference, there won't be no flow of charge. Without potential difference, no flow of charge. No flow of charge or no current. So that's the reason if I keep the potential difference 0, oops, here charges are not flowing, so that's the reason the bulb is not working. Now if I give the potential difference, so the more potential difference we give, so the more amount of the energy existing. Now with the potential difference, the potential difference is there between the across the cell, and the same potential difference causes electrons to move. So here you can measure potential difference across any point in the circuit. So this is the potential difference across the bulb and across the cell. Or if you want to measure the potential difference between the two ends, so at any point in the circuit we can measure. So we will talk more about this concept, how the potential differences changes. So this is, I need to connect properly. Yeah, so here also you can see the potential difference across the cell is 38.5 volt. So without the potential difference, so there won't any flow of charge. So that is the importance of potential difference. So here we define potential difference. According to definition of potential difference, the work done per charge. Potential difference, we can represent potential difference with a symbol V. So its formula goes to work done per charge. Work done by the charge to move an electron throughout the circuit. So that we define as potential difference. So we know the work units are joules and charge units are coulombs. So joule per coulomb, we will write that as volt. So the potential difference units nothing but volts. So this is the necessary component which is needed to the circuit, that is battery or cell. So the battery contains electric energy. That electric energy is used by the electrons in the circuit. That electric energy comes due to because of the chemical reactions and chemical components which are present inside the cell. So if that chemical reactions gets over, then the potential difference of the cell becomes 0. Now in this case, the cell is dead. All the chemical component and the chemical reactions inside the cell, they got over. Now electrons, they won't flow, they do not contribute any current, so we won't get any light if we connect it to the bulb. So once if you give back, now again if you think at here the cell is recharged, so like that we are recharging our phone whenever our phone battery gets over. Now again the cell is recharged, again the cell is having a potential difference. Now the electrons are moving in the circuit, so it is contributing current. So finally I can define the cell is very needed component to move the electrons in the circuit. So cells contains chemical energy. So they convert chemical energy to electric energy. So when a battery is in a circuit, the electrical energy is carried by the electrons that move around the circuit, and this is converted into other forms of energy. So likely here, if we can see, if there is a bulb in the circuit, it is converted from, here it is electric energy is converted into light energy. So the amount of electric energy the electrons have at any point in a circuit is known as potential. The definition of potential: the amount of electric energy the electrons have at any point in a circuit is defined as potential. As they move, the electrons transfer energy in the other forms. So if you take at any 2 points, the electrons have different amount of energy. So when the switch is on, then only the potential difference works. The 6 volts potential difference is existing between the 2 points. So as they pass through the bulb, some of the energy is converted into light energy. So electrons which have passed through the bulb, that electrons charge is used by the bulb. Now they are having less potential energy. Now if I measure potential difference at here and at here, so this will be across 6 volts. If I take this cell is 6 volt. Always there will be higher potential at point and lower potential at point. So this is we defined as potential difference. If there is no potential difference, there is no flow of charge. So this is how we define potential difference. So what was potential difference got to do with voltage? So potential difference or voltage of a battery is measure of electric energy given to 1 coulomb of charge passing through the battery. So potential difference or voltage. Voltage is units for potential difference of a battery is a measure of electric energy given to 1 coulomb of charge passing through battery. Let's guess this. Potential difference or voltage V. Suppose a 9 volt battery will give how much energy to each coulomb of charge passing through the battery. So according to this previous definition, suppose if 1 coulomb of charge is flowing, through battery, so if 1 coulomb of charge is flowing through the battery, so how much amount of energy is giving? It is given by the 9 joules. Otherwise you use this formula, potential V equal to work done per charge. So here potential is given 9 volt and charge is given 1 coulomb. So here how much I shall write? So here it is 9 joule. So a 9 volt battery will give 9 joules of energy to each coulomb of charge. So finally we define this in a simple formula, potential V equal to work done per charge. So potential units are volts. This is all about potential difference.